Okay, grade 12, let's look at working with codes and passwords. I really love this section because it links the counting principle into exciting stuff with passwords and codes. Okay, now let's have a look at an example. It says a password is to be made up using the format AAABB, where A represents any digit from 0 to 4 and B represents any letter of the alphabet. How many different passwords can be formed in each of the following cases? Now, before we do it, let's see what a password looks like. Well, if you take the digits, let's have a look here. If you take the digits here, if you look at them, what would be the digits? Okay, they're going to be 0, 1, 2, 3, 4. So there's actually 5 digits or numbers that will form the first 3 positions in a password. So for example, you could have 3, you could have 0, you could have 2 as a possible password with 3 numbers. Or you could have, for example, it could be repeated, you could have 3, 3, and 4 as a possibility. Then in the remaining 2 positions, we have 26 letters of the alphabet. So you could have an A here and, J there, or you could have an H and an H repeated. These are passwords made up. The first 3 positions of the password would be digits, 0, 1, 2, 3, 4. There's 5 of them, and there are 26 letters you could choose for the remaining 2 positions in the password. Now it says the digits may be repeated as well as the letters of the alphabet. So if you want to create a password like that, well, let's see. Okay, let's clear this and give ourselves some space and have a look at what we can say. Well, look at this. Well, if you've got the first 3 positions occupied by digits and the last 2 positions occupied by letters, well, for the digits, there are possibly 5. They may be repeated. So any of those guys, there's 5 of them, could occupy the first position. How many could occupy the second? Well, you can repeat, so we can use 5 of them, and we can use another 5, any of those 5, in the third position. Now, with the letters of the alphabet, there are 26 we could have used in the first position, and because we can repeat, we can use 26 in that position there. So according to the counting principle, how many passwords would there be? 5 times 5 times 5 times 26 times 26, which would give you 84,500 different passwords. Okay, pretty cool. 5 digits, 0, 1, 2, 3, 4, and 26 letters of the alphabet. Now here's another interesting one. What if you may use these digits and the letters of the alphabet? They're 5 digits. Okay, 0, 1, 2, 3, 4, and there's 26 letters of the alphabet. A, B, C, D onwards. Okay, but you may not repeat the digits or the letters of the alphabet. So let's look at the first 3 positions, which would be the digits, and then the last 2 positions, which would be the letters. Now, of those 5 digits, you can use 5 in the first position. So you might decide, hey, I'm going to use 1. So let's have a look. We're going to take 1, and we're going to use him, and we put him over there. There's your first digit. Now we're down to 4. So we only have 4 that we can choose now. So we might decide that we're going to use 3. Okay, so let's bring 3 down, plonk him in there. Now we're down to 3 that we could use. So here we go. We've only got 3 there. Remember, we've got 3 positions, so we might decide that we're going to use 2. Okay, there we go, and bring 2 in. So we've got that. Now we're not going to use those other 2. We've got 3 digits. They may not be repeated, so we couldn't have 1, 3, 3. But there we go. We've got 5 digits that can be used in the first position, 4 in the second, and 3 digits in the third position. Of the letters, there are 26 that you could use. Say let's use the letter D. You can't use it again, so we're down to 25. So how many passwords could we have according to the counting principle? 5 times 4 times 3 times 26 times 25, which, if you work that out, is 39,000 passwords. Okay, let's have a look at another one. The digits, so we've got 0, 1, 2, 3, 4, 5 digits there, and 26 letters. Okay, and there's our 3 positions for the digits and 2 positions for the letters. The digits and letters may be repeated. They may be repeated, but the number naught must be excluded. So let's exclude naught, giving us 4 possible digits, and the vowels must be excluded. Now, what are the vowels? A, E, I, O, and U. So instead of 26 letters now, we're going to be subtracting those 5 vowels, so we're down to 21 letters. So the letters may be repeated, so we can go 21 and 21 there in the second position for the letters. But if we exclude naught, we have 4 possible choices for the first position for the digits, 4 for the second, and 4 for the third, because we may repeat those guys. Okay, so from the counting principle, how many passwords could we have? 4 times 4 times 4 times 21 times 21. Work that out, and you get 22,224 possible passwords. Okay, now have a look at this. We've got the digits 0, 1, 2, 3, and 4, and our 26 letters of the alphabet, and the vowels are A, E, I, O, and U. Now it says they may not be repeated. We're not allowed to use the number naught, so let's remove naught, and we're not allowed to use the vowels, so we're down to 21 letters of the alphabet that we can use again. Okay, so there's the first 3 positions for the digits and the first 2 positions for the letters. So we may not repeat, so we can pick of those 4 digits, we can choose 4. We decide we're going to use 3, so now we're down to 3 options there. And then do we decide we're going to use 4? So now we only got 2 left there. So 4 digits can occupy the first position, then 3, then 2 digits, because we're not allowed to repeat. And likewise with the letters, if you use 21, you can pick any. If you're using 21, you pick one. There's 21 choices, then we're down to 20, because you may not repeat. Remember that we've had 26 letters, we've removed 5 vowels. So 26 minus 21. 26 minus 5 is 21. So from the counting principle, we have then how many possible passwords? 4 times 3 times 2 times 21 times 20 gives you 10,080 possible passwords. Okay, how about this one? Here's the digits. The digits may be repeated, so there are the digits there, and we've got 26 letters. Okay, but now watch this. It says that the digits may be repeated but must be prime numbers. So what are the prime numbers? 2 and 3. So we scrap 0, 1, and 4. They're not prime. So we're down to 2 digits here. Okay, so we've got 2 digits that we can use. Then we're not allowed to use the first 5 letters. So we've got A, B, C, D, and then we've got V, W, X, Y, and Z. And there's an E there. So those are the first 5. The last 5, so we subtract 10, so giving us 16 possible letters that we can use. So let's see, what are the possible passwords? Well, they may be repeated, so we can choose 2 digits there, 2 digits there, 2 digits there, and then we've got 16 and 16, because we may repeat. So from the counting principle, how many passwords do we then have? Would be all of those. 2 times 2 times 2 times 16 is 2,048 possible passwords. Okay, now here the last one, the digits may be repeated, so they must be prime, so we can use 2 and 3. There's 2 digits there, and then we may not, and we've got to exclude the first 12 letters. So if we've got 26 letters, we subtract 12, we're down to 14 letters. We're scrapping the first 12 letters there. Okay, great. Now, what are the possible passwords that you could have? And they may be repeated. The digits may be repeated. So that's 2, and 2 and 2. So there's 2 there. We can use them in all 3 positions. And then we may not repeat the first the letters, so we have 14 letters because we're scrapping the first 12, so we're down to 14. We may not repeat any of those 14, so we're down to 13 in the remaining 2 positions there. So from the counting principle, we have 2 times 2 times 2 times 14 times 13, which is 1,456 different passwords that we could use. Okay, that we could have. Okay.